Full bridge PWM motor driver A3953 by Allegro Microsystems. Welcome to the training module on A3953. This training module introduces the features and applications of this device. Our training outline consists of features and benefits, internal block diagram, typical application and brake mode operation, and additional application information. The A3953 is designed for bidirectional pulse width modulated current control of inductive loads. It is capable of continuous output currents to 1.3 amps and operating voltages to 50 volts. Internal fixed-off time pulse width modulated current control circuitry can be used to regulate the maximum load current to a desired value. The peak load current limit is set by the user selection of an input reference voltage and external sensing resistor. The fixed-off time pulse duration is set by a user-selected external RC timing network. Internal circuit protection includes thermal shutdown with hysteresis, transient suppression diodes, and crossover current protection. Special power-up sequencing is not required. The mode input determines whether the pulse width modulated current control circuitry operates in a slow current decay mode or in a fast current decay mode. The A3953 contains a fixed-off time pulse width modulated current control circuit that can be used to limit the load current to a desired value. The peak value of the current limiting is set by selection of an external current sensing resistor and reference input voltage. The internal circuitry compares the voltage across the external sense resistor to the voltage on the preference input terminal, resulting in a transconductance function. In this slide, we discuss about load current path and its timing diagram. In forward or reverse mode, the current control circuitry limits the load current as follows. When the load current reaches current trip, the comparator resets a latch that turns off the selected source driver or selected sink and source driver pair depending on whether the device is operating in slow or fast current decay mode. In slow current decay mode, the selected source driver is disabled. The load inductance causes the current to recirculate through the sink driver and ground clamp diode. Brake mode operation. When a logic low is applied to the brake input, the braking function is enabled. This overrides enable and face to turn off both source drivers and turn on both sink drivers. The brake function can be used to dynamically brake brush DC motors. This slide offers information about generation of synchronous fixed frequency control. The internal pulse width modulated current control circuitry of multiple A3953 devices can be synchronized by using the simple circuit. A 555 IC can be used to generate the reset pulse or banking signal for the device and the period of pulse width modulated cycle. The value of T1 should be a minimum of 1.5 milliseconds. When used in this configuration, the RT and CT components should be omitted. The phase and enable inputs should not be pulse width modulated with this circuit configuration due to the absence of a blinking function synchronous with their transitions. When the device is operating in slow current decay mode, there is a limit to the lowest level that the pulse width modulated current control circuitry can regulate load current. The limitation is the minimum duty cycle, which is a function of the user-selected value of T off and the minimum on-time pulse T on max that occurs each time the pulse width modulated latch is reset. The user selects an external resistor and capacitor to determine the time period during which the drivers remain disabled. For 3.3 volt operation, the minimum recommended value for a capacitor is 680 picofarads, plus or minus 5%. For 5 volts operation, the minimum recommended value for the capacitor is 470 picofarads, plus or minus 5%. In this slide, we list useful application information for using this device for stepper motor application and DC motor applications. In this slide, we show an application block diagram for motor control through pulse width modulation. In closed-loop systems, the speed of a DC motor can be controlled by the pulse width modulation of the phase or enable inputs, or by varying the reference input voltage. In digital systems that are microprocessor controlled, pulse width modulation of the phase or enable inputs is typically used to avoid the need to generate a variable analog voltage reference. In this case, a DC voltage on the reference input is typically used to limit the maximum load current.